Thank you for the nice introduction. Hello, good afternoon. Welcome to my presentation about a very long title. I have even to read it, Field Experience in Flood Alerting, Stormwater Detention, Basin Management, and Water Quality Monitoring. Good. So who is DecentLab? He gave already a quick introduction. We are the wireless sensors and LoRaWAN experts. We have customers in about 70 countries, and we have been in business even before LoRaWAN. We did some legacy wireless mesh network and so on. Our company is founded 2008. Our company is in Switzerland. We do the engineering, the design, and the manufacturing there. So it's a small team. We are 6, but we might look for to hire more people. We've done that since 2008. That's why we have grown a portfolio to more than 40 different sensors. Our key use cases are mainly in the water cycle as we come out. That is a large portfolio. We focus on outdoor and harsh environment, as you will just see in the next minutes. Here again, the coverage where we are active in Europe, mainly North America and some Asian countries. So we have seen a lot about LoRaWAN, wireless technology, electronics. But when we go in such use cases, the challenges are way more other dimensions. So if you deploy for such use cases in the outdoor, your device has to be, first of all, very robust over the next 10 years in the field. Also, you have to maintain the accuracy of your measurement and the precision. If you're there, you have changing climate, and also, so we have to have a high lifetime, if even a high sampling rate, because it will cost you a lot to install such a device. So in the design, you have also to bring that. I don't talk too much about the range. LoRaWAN we have covered a lot. Security is also key, that it's kind of locked or against vandalism or also security from a software perspective. And sure, costs is always challenging, especially in the beginning, to bring it up. For flood monitoring, or this challenge we have is when we talk about range, overground, it's perfect. We have many kilometers of range. We have 180 kilometers. But as we go to the underground in the sewer level, so it will shorten down to maybe 200 meters. I think we have seen that. But this is always an issue, or just to know. And when we talk to the customers, when you go underground, it's totally different as when you're overground. And fortunately, all the LoRaWAN networks have heavily developed, so gateway locations are far less the issue as we started some years before, as all you know. If you have good gateways, that's also a good thing, but you have also, and LoRa is a good technology, but you have to tune your device really to match the maximum that you get your range. And that's what you see from real measurements in the measurement chamber, and we are kind of proud to have that 365 degrees. So how does it now look in the field, what you do? So in these pictures, you see several installations in Brazil, in Scotland, in Hong Kong. And what you see as first thing is every site is a bit different. And so the mounting and the installation is each time a bit different. Okay, it's similar, but this is also when we roll out outdoors in contrast to indoor. You have not to underestimate the effort to do the rollout and the deployments. Here, another setup with our flood monitoring, the ultrasonic displacement sensor. This is settlement water, where we have in cities a lot of small channels where the water is going overground, the small creeks, and at a certain point they go underground. Before they go underground, there is this, infrastructure to hold back the debris, the branches, And so here we have a high danger. When you have a strong and a heavy rain event, it can happen that you have a lot of debris and that piles up. And so in a strong rain event, we can have immediately filling up and then flooding the neighborhood. That's why we have many such rollouts in large cities that it needs minutes to get away, or you have to have an alarm because they can quickly raise and you have to go immediately and fix it. And normally in heavy rain events, people have no time or is always stressed, but we help them to prevent floods in the cities. Here you can see a real flooding just next to our offices. And you can see on these plots, the rain event was very, very short, but very heavy. And so this is in minutes, in several minutes, or 10 minutes, 20 minutes, where such events can happen. And so you have to block the road, or you have to clear or make some emergency changes. When we go underground, we have even more challenges for the sensor. As you can see here, we are measuring in the sewer network. And then you have the geometrical shapes, which are not that easy to measure. So when we measure with an ultrasonic sensor, you want to have a flat surface, but this built infrastructure, they have shapes where we don't get so easily measurement. So it's always also challenging from that perspective. And it never repeats the same thing, but you learn. And as well, wastewater can build foam and waves. So the measurement of these applications, we need always to go to new ideas and adapt. Robustness and maintenance. I show also some things which are really happening in the field. So we have here this ultrasonic sensor. It has to have a tube to get this trumpet, to have this 10-meter range to measure. On the other side, we have to look at that can happen, that we have like things entering, and you also need to maintain these. Even they're low maintenance, and sometimes things happen but when you have a lot of them, most of them like all the time. Here that was from before the range and installation, again comparing the simple, the easy one to the more difficult one. We have challenges in the city. When we are in the city, we can become, with our devices, also a place to put art. I think that was a nice upgrade on the right side. Make it even better, a nicer device than with street art. Then we have our own logo. On the left side is sometimes you're obliged to monitor really where people are moving, and you want to measure at the people's height, and sometimes that can be a bit challenging. But overall, I have to say, after we have so many thousands in such applications, such things happen very rarely in most places. So I want to show and move away from this flood monitoring. We also do this level monitoring for hydroelectric power generation. So we have seen in this drought heat wave in Europe, where drought was lowering the river levels. And so we can do monitoring of the level with our pressure level gauges and help this hydroelectric power generation to monitor the level, and also guarantee for the environment that it's still enough water in the river. This is another use case where we measure now underground water, but the groundwater, or here the tank level for water distribution. This is a smart city application, but this smart city is in a refugees camp by UNHCR. So this is in fact cities, refugees camps, and LoRaWAN is a great solution to roll out infrastructure in not so in challenging environment, and you can easily build utilities application or metering. And so we have helped here to make the tank level measurement, but also to monitor the groundwater and boreholes, that the pumps who are pumping up the water don't run dry. Because when you have a dry running pump, it will die and you have to replace it. Further, we help for the continuous monitoring of the groundwater, that there's a sustainable groundwater table. So UNHCR can show over several years that the groundwater table is not going lower and lower, so it's sustainable what they do. In this application, we use the same, not for groundwater, but is again like a water or a heavy rain event use case. We have here this level gauge, as you see, for the river level, but here it's installed in a district heating channel or chamber. On the very right, you see the district heat pipe, and this is the below ground. And with this, we monitor the leakage means, and if it's flooded by rain. So this city has the issue that in heavy rain events, these rooms are filled up with water, these chambers, or they don't know if it's from the district heating. So by measuring the level and the rise of the level and combining also with the measurement of the temperature, you can decide, was it due to rain or was it due we have a leakage in our district heating. And so I'm moving now from level and flood monitoring towards other water-related use cases, because in many regions, water become a very expensive good, and you want to use these resources very efficient. So in the countryside, it's hard to distribute the water, and also you want to save in many regions the water. Here you see that we do with soil moisture monitoring, and them also helping with the water distribution to save water and to improve their yield, and so go forward with that. Here, again, with the level monitoring, we have it in the countryside, and we have it on the other side in the city. It shows the different ways to save water or to optimize. I just skipped that. It goes in a similar direction. What I can say is we have worked with many research institutions in the water business, and we delivered to them the relevant devices to measure the levels. And here they measure the gradient of a river towards the sea, and they want also see how much the sea impacts with the salinity, or with the salinity into the river, and also with the wastewater, the mix up. So that's why we measure here this information. I'm coming towards to the end. As we were working now for many years with water level and flood monitoring, we have our customers were approaching us that they also want to use more and more use cases where there is quality parameters relevant. So that's why we have now extended for the wastewater treatment plant or for construction sites to make these water quality parameters monitored, which are easy to maintain and to roll out, and which have also low operation cost, because you have not difficulties with the sensors. That's why we have now 3 water quality parameters which we identified as the most robust and covering the relevant use cases. So we have turbidity monitoring, which monitors the dust in the water, and which may settle before you release your wastewater into the open water again. We have the dissolved oxygen sensor, which is used in water treatment plant to monitor for the bacterial life that you don't make it in a situation that you lose your conditions. And we have the electrical conductivity measurements where we can early detect changes in the water, that the pollution happened, but also that we see salinity or other contaminations. So I come to an end to my presentation, and looking forward for upcoming discussions either here or visit us at our booth. And thank you for your attention.